So here's part 2 of the notes here, and again, we're just looking at secants in circles and how they relate to circles. And our key question for the day is where are the secants located? If you just write this in the margins and write a little star here, I'll be able to know that you are watching these videos, and that's another sign to me that I can get you that extra credit. Okay, so we're looking at where, and before we looked at what happens when the segments are inside, but now we're going to talk about when the segments, or even just part or some of the segments, are outside the circle. Okay, and that's our keyword outside there. Well, if you look over here, we have two segments, right? There's ED, this longer line, and EB, okay, but they're split into parts. ED right here, this would be like the whole segment, but notice that it has a part, EC, that's outside of the circle. Okay, that's outside of the circle. So if we took away the circle, that part would still be left. It's outside of the circle. And again, if we have EB here, well, there's still a part, EA, right here, that's outside of the circle. And actually, anytime we have that sort of situation, all right, that sort of situation where we have the outside and we have the whole thing, we're just going to multiply the external, or the outside, and the whole. And again, that word external just means outside. So external times the whole equals external times the whole. Okay, and that's supposed to be an R right there. External times the whole. So again, just to color coordinate it here for us. Okay, we put the externals in pink. So this would be like the external, the pink one, which is EA, right? EA, times the whole, which we highlighted in yellow. That would be EB, the whole thing here. Times EB. Okay, same thing for the other line. So that equals the external, or EC, times the whole, ED, which we highlighted in yellow. Okay, so that's how we're kind of working it, and it's always going to be this when it's outside. So if we have any part of the segment that's outside, we're doing external times the whole equals external times the whole. So let's look at a couple of them. If we look at A right here, okay, I see that these parts are outside, right? The 3 and the 4, those are both outside. And I see that they gave me one of the wholes too. The whole is X. Whole is X. But I don't know what this whole is. I need to figure out what this is. Well, if this part of the line is 4 and this part is 8, I can add these together and get 12. That's the whole. Okay, and I just added these to get 12. Well, now that I have all the parts, I have the externals and I have the wholes. I can do external 3 times the whole times X equals external 4 times the whole, which is 12. All right, and we're just doing 3x equals 48. And then we just divide by 3 and get x equals 16. And that was relatively painless from like a math side point. You know, just quick, easy steps after that. If we look at B, okay, we see that we have part of the segment that is outside. All right, so we know we're doing that outside part, okay, that outside formula, if you will. And here's our whole line. We want to figure out what is the whole thing. The whole thing. Well, this one's pretty easy. 4 plus 6, right? I'm just going to combine these, and that's 10. 10 is the whole thing. The whole thing over here, well, again, we're just going to combine these, and we get 7 plus x. That's the whole thing. That's the whole thing, 7 plus x. Okay, so when we go in and we do this, we're doing external, or 4, times the whole thing, 10, equals external x times the whole thing. That's 7 plus x. 7 plus x. So as we can see, we need to do some distributing here, right? If we see these parentheses, we're thinking, okay, distribute. So that would be 40 equals 7x plus x squared. 7x plus x squared. And if we subtract the 40 over, right, we're going to subtract this 40 over. Then we're going to rearrange some things. We can get x squared plus 7x minus 40. Minus 40. Okay, and at this point, we're going to try and, we see this polynomial. Remember from algebra, we're going to try and factor it. But if we think about it, there's nothing that we can do to get plus 7, right? Because 40 would be like 4 times 10, 4 times 10. But even if we did a positive 10 and a negative 4, right, the best we could get would be plus 6. So instead, we're going to use the quadratic formula. And hopefully you remember this from last year. But the quadratic formula is negative b plus b squared minus 4ac all over 2a. Right? It looks like that. It looks like that. So we're just going to plug these in. Remember that it's the coefficients. The coefficients, and then c is at the end. All right, so we're going to go, and there's a 1 there. There's an invisible 1. So we're going to go x equals negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 40. And then that's all over 2 times 1. All right, and that long thing, when we simplify the inside, we get x equals negative 7 plus or minus the square root of 209 all over 2, and we can actually leave it just like that. That can be our answer, okay? So don't feel like you have to type that into a calculator or anything. Just leave it like that. Okay, so as you can see, these can get a little tricky, a little messy maybe in the math, but the concept is actually really simple. So let's just go back to that concept just so we're not intimidated by that math. We'll do one more. Okay, and to me, this actually kind of looks like a face, like maybe the eyes would be over here, and then this is actually the guy's nose, and it's maybe got some like nose hairs coming out of it, and maybe he's got like an eyebrow, or maybe he's got 2 eyebrows, or maybe he's got 1 eyebrow. I don't know. That kind of looks like 3 eyebrows now. I don't know. It's kind of weird, but draw me something here, some sort of face, so I know you watch these videos. Okay. But here we see the outside, so the externals, and then again we're looking for these parts, and we're looking for the whole. Okay, and the way we get these wholes is by adding them together. So that would be 10, and then we're just going to do external 5 times the whole times x equals external 6 times the whole times 10. Okay, and again, this is really just the basis of the process when the segments are outside. Okay, so this is really just the heart of it. So as long as you have this, you'll be fine. Don't worry about all that messy stuff we just did in the last problem. As long as you can do external times the whole equals external times the whole, you'll be fine. You'll be a-okay.